All right. Unit 1, perms and cons. Oh, it's going to sound like I'm yelling again. That's what it's going to do. Sorry. Enjoy. All right. Maybe if I put the mask on, it'll muffle it. Tone me down, you know? All right. So the chart has perms and cons on it. And it's just at the very top in front of your lesson plan because I want to be able to refer back to it once I've taught you permutations and combinations and the difference. So right now, if you looked at it, you'd be like, I have absolutely no clue what that is. You shouldn't. You've never been taught it. So we have this up here just so I can say, hey, everyone, flip to the very front of your notes booklet by the end of this week. Okay? And then we'll come back to this. So keep that in mind. So this is your lesson 1, fundamental counting principle. So you consider a task made up of several stages. If the number of choices for the first stage is A, the number of choices for the second stage is B, and the number of choices for the third stage is C, etc., then the number of ways in which the task can be completed is A times B times C times however many more tasks there are. It's called the fundamental counting principle. So that's just a definition. We're going to go through an example. Example 1. So we're looking at a toy manufacturer makes a wooden toy in 3 parts. Now the key thing is that we need all 3 parts of this toy to make the full toy. Okay? So we're going to need a top, a middle, and a bottom. So up here it says, consider a task made up of several stages if the number of choices for the first stage is A and the number of choices for the second stage is B. So here we have 3 stages, right? Part 1, part 2, part 3. Now, we are going to go through and we're going to do a tree diagram first, representing the top part, which is colored red, white, blue, or pink, the middle part, which is orange, purple, or black, and the bottom part, which is yellow or green. Okay? And the reason why we're going to do a tree diagram is so that you trust me when I say the fundamental counting principle actually works. Because the tree diagram is going to show us all the different outcomes of the toy. So when we go to do part 1 of a tree, normally you do a tree stand tall, right? And you're going to try and do that. These trees are going to go sideways, more like a shrub. We're going to do a shrub diagram. Okay, so we have part 1. Now, when you go to list the colors, please leave spaces between them because off of each of these colors, you're going to have 3 branches where you're going to have to write orange, purple, or black, right? So we're going to need to leave spaces between each word. So part 1 can be red, white, blue, pink. That's your part 1. Then we have part 2. If we only had part 1, if there was only a part 1 of this toy, we could have 4 toys total, right? 4 different toys. That's it. But we don't. We have a part 2. And each part 2, each middle part is orange, purple, or black. So if this thing had only 2 parts, how many toys would we have? A red with an orange middle, a red with a purple middle, a red with a black middle, so 3. White with an orange, a white with a purple, a white with a black, so 6. So 12. Right? So if we only had this and this, so that would be, how many parts does this have? 4. Times how many parts does this have? 3, right? So we're proving it's working. It's working so far. And part 3. Anyone have like a tickle in your throat and you don't even want to like tickle your tickle out because people will think like they'll look at you weird? Yeah. I'm like ready to sneeze, and I'm like, pineapple, pineapple, pineapple. You can't sneeze. You can't sneeze. Pineapple, like I'm trying to get sneezes to go away. It's a little bit of a weird world we live in, but not Ebola, right? Right. Okay. Bottom part, yellow or green. So off of here, we have yellow, green. Then I'm going to get lazy. Yellow, green. On a diploma or on a unit test, could we just go YG? Would we want a short form ever on a unit test or on a diploma? Would we ever want to short form and have someone assume something? No. So if we're going to try and use our pencil out, it'd be on a test or on a diploma, right? You're going to try and run out of lead. That's how much you're writing. Okay. So, could you go, someone asked us in the other class, could I go Y, let Y equal yellow, and then use Y's? Totally. So if you want to off this side, go let Y equal yellow, and then put Y's, you've given that Y a variable, and given it what it stands for, so you could totally do that. That was a good question in the other class. So we had 12 toys, and what did we actually do with each of those 12 toys? Give them each how many more options? 2 more options, right? So we're going from having 12 toys to actually having 24 toys, right? And so that's why the fundamental counting principle, so if we, when we put the blank down, we're saying we have 1 option for part 1. And then we go, we have 1 option for part 2. That blank means I'm choosing 1 option. I'm choosing 1 option for part 3. So like 1 top, 1 middle, 1 bottom, right? If I could pick like 2 colors for the middle, I wouldn't be able to use the fundamental counting principle. I'd have to do it a different way. So I can only choose 1 of the options. So like we were saying, we had 4 options. So up here we list the amount of options. 4 options for part 1. 3 options for part 2. 2 options for part 3. And we can multiply them, which gives us 24. 24 different colored toys. So I use the tree diagram just to show you that it actually works and why it works. Because you're taking that 4 toys, you're splitting them into 3 more options, right? So 12 toys, splitting those 12 toys, 2 more options each. So 24. Okay. Here, a school cafeteria offers sandwiches made with fillings of ham, salami, cheese, or egg. And those are on white, whole wheat, or rye bread. How many different sandwiches can be made using 1 filling and 1 type of bread? 1 filling and 1 type of bread. Okay? So I told you you can only choose 1 of each thing, right? So if they said 2 fillings, could we use the fundamental counting principle? No, we'd have to do something else. All right? We can only choose 1 of each piece. So the fundamental counting principle, we're going to go blank filling. So we're doing 1 filling and 1 bread. Because we need the filling and the bread to make the sandwich, not the filling or the bread to make the sandwich, right? If it was or, you'd have the filling or you'd have the bread. You wouldn't have sandwich, you just have groceries. Okay? The key reason why is, this is something to note up here. Whenever you use the word and, you are going to multiply. So because we use an and here, we're going to multiply. Or we'd actually add. you know how she just literally just passed the class? She's like, anyone have social? The media? Me? Nothing. I got nothing. I ain't getting introduced. Yesterday, funniest thing? Oh, I'm totally saying, whatever. It's getting recorded. Yesterday, the funniest thing is that they walked past and they're like, yeah, this is Matt, and this is Mr. Clay, and this is Mr. Crawford. And I was like, I'm just Matt. Hello, Matt. How are you? Like, I don't get a name. Like, what the heck? Yeah. Here's Matt, and then Mr. Clay and Mr. Crawford. And I was like, I have a name. It's real. I'm recording it. Whatever. Okay. So, filling. How many fillings are there? They're in red. How many different fillings? Yes, 4. Remember, you can answer because you're spaced apart. That's okay. All right. And bread, how many times? How many types? 3. Good answer. That was a believable one. You knew it. Thank you. Okay, so that's 12. I'll answer it for you guys because it's been a tick since you've been doing some math. 4 times 3 is a tough one. So what did we get? We got 12 what? 12 different. Yeah, yes, 12 different sounds. And the different makes a difference because they could be the same, and then what the heck is that? So with perms and comms, it's a little weird because all the questions are a little different, so we go through them together a lot. In a lot of the other units, it'll be like, we go together, I teach it, we could do together, you work on a few and try them, right? These are all kind of a little different. So if I unleash you, you're like, I don't even know where to start. This is awesome. Okay. So when we go to start fundamental counting principle questions, we always have to figure out how many parts of whatever it is we have, right? So this one, the different parts were the filling and the bread, so we did 2 lines. The other one, there was 3 parts, so we did 3 lines, because there's 3 parts to the robot, right? So we're like here, a Math 30 quiz consists of 8 multiple choice questions. How many parts does this test have? Trick question? It's not. 8. Yes, it does. Oh, show. So we're going to draw ourselves how many lines then? Led you into this. Same answer. 8. Thank you. Yes. Okay, we're going to draw 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. Now, do we have to, when we're doing a test, do we have to do question 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8? Usually? Okay. Does the teacher ask you to do them, but you may not? Yes. If you don't want a good mark, I guess you could skip some. Sure. This is true. So we want to do number 1, number 2, number 3, number 4, number 5. So we want to do these ones and, right? So because it's ands, we're going to multiply. Now the key problem in fundamental counting principle is that you guys know to multiply, but you forget to put the dots. And if you don't put the dots, you're not actually showing the algebra, right? You just have numbers on lines. It's actually just a really large number if you have no dots in between. Now, we know that this is question number 1, and this is question number 2, and this is question number 3. Number 4. And I'm filling all this in before even reading the whole question because when I do fundamental counting principle, one of the biggest things I need to figure out is how many parts there are. Now, each question has 4 choices, A, B, C, or D. So, what number goes above this blank? How many choices do I have?
4.
4. Yes. Good job. 4. And then what about number 2? 4. And then what about number 3? 4. Number 4. 4. And then 5. 4. Because there was no restrictions on here, right? It wasn't like, and number 8 is A, right? If they said like number 8 was A, then number 8 would only have one option, right? So people will tell me that's 4 times 8, but that's not 4 times 8, is it? That's 4 to the power of 8 is what it is. So we're going to go, I already have it on there. Put down marker. though it's there already. 65,536. So there's 65,536 what? What do we just find? Usually it's in the question. Yes, different sexes. So those people who don't study and think, I doubt these are you guys, but people who don't study and think they're going to get 100% on an 8-question multiple choice by guessing, they have a 1 in 65,536 chance. Probably not happening, but you know. So how could they tweak this to be, a diploma style question where it's not like I have 8 questions, they have 4 answers each, right? What they could say is, Mrs. Lepp is excited to mark all of these quizzes that she handed out. They are going to be amazing. She goes to mark them, and while she goes to mark them, she hits over her coffee cup, and it spills, and it washes out questions 3 to 8. The answers to 3 to 8 are gone. So she had an answer key, 3 to 8 gone, right? So I still have an answer key with 8 blanks, but numbers 3 to 8 are washed away on my answer key, right? So I need to deal with the ones that are still there. Number 1 and number 2, right? Their answer keys are still there. I'm not doing this on the whiteboard, so no one is seeing this. I think it's like they can't see anything. I tell you sometimes. I've been out since March, okay? In this physical classroom. And it's showing. All right. 1, 2, 3, 4, 5, 6, 7, 8. Number 1 and number 2 were not washed away, right? So do we know what those answers are? Technically, yes. Could it be A, B? Could it be B, A? Could it be C, D? Could it be A, C? Does that matter? No. What matters is how many options do I have for number 1? 1. It's whatever the heck it is, right? I don't know what it is, but I don't care. It's whatever it is. What about 2? How many options? 1. And then what about 3? 4. Now I'm back to the 4s again, right? Because those all got washed away. And then people tell me it's 4 to the 6. What's my problem here? Well, why wouldn't I get full marks? Don't have the multiplication dots. Honestly, that's a lot of people, you forget them. So don't forget to add them. And don't do them so faint that on the diploma, we're standing there marking it, and we're like having to hand it to 4 more people to stare at it to decide if there's a dot or not a dot. Like, do you see a dot? I think I see a dot. Do you see a dot? Maybe. Is that just like a tap on the page, or did they actually need to put a dot? Don't be that for it. Like, show your dots. Be proud of those dots. You put them there, you know? Like, yeah. All right. Example 4. In how many ways can 5 different models of black cars and 4 different models of red cars be parked next to each other? Now, there's a big thing here about different. That's very important, the different. Because if I have the same black car parked, let's say there's 5 of them, right, and they're the same model. If I park the black cars in a row, B representing the black car, right? And they're the exact same model, and we're pretending that I actually drew those all perfectly the exact same, which I didn't, but we're going to give me a little grace here. They all look the same, okay? If I tell you to close your eyes and cover your ears and stick you in a box so you can't hear anything or see anything, and I actually take these 2 cars, oh, that's good. Made that one really big and obvious. I switched those 2 cars. Let's pretend they're all the same. They are not. I just pretend they are. And you opened your eyes and you looked, and I said, did I move the cars? What would you say? No, you didn't. I can't tell the difference, right? So they would be repeating. We would call them repeating, which we'll deal with next. Not today. These are not repeating though. These are different models, right? So they would look different. One would be like a Ford Mustang and one could be like a Ford Focus. And one could be like super different. Okay? So those would be represented by black car 1, black car 2, black car 3, black car 4, black car 5. Can I see a difference in the cars now? Yeah? So I tell you to close your eyes. Cover your ears, stick in the box, can't see, can't hear. And now I go and swap these two. I really can't get that beeper. Now, could you tell the difference? Yeah, you'd say they moved, right? So they don't look the exact same. So when they don't look the exact same, you don't have to treat them as a repetition, which we're going to deal with tomorrow, okay? So these are all different looking. We can tell the difference. If we move them around, we can see the difference, okay? So we have 5 different models of black cars and 4 different models of red cars. How many cars total do we have? 9. So we have 9 in total, and they must be parked next to each other in a parking garage. This is the catch. If a black car must come first, and a red car must come last. So those are my restrictions. It's restricting me to having a black car coming first and a red car coming last. Okay? Up here it says, when solving problems involving restrictions, the restriction must be dealt with first. So I'm going to have to deal with that black car coming first and that red car coming last. First. Okay? How many parts do I have to this? So in this case, it's how many cars am I parking? There's 9, right? I'm parking 9 cars. I'm parking all of them. So how many parking spots do I need? 9. Park all the cars. So I'm going to need 1, 2, 3, 4, 5, 6, 7, 8, 9. And my restrictions are, this one needs to be a black car, and this one needs to be a red car. Okay? So this black car, how many options do I have for this? 5. And the red car isn't affected by that. How many options do I have for it? 4. Now, silly Crystal back in the day would have been like, I parked 9 cars, parked 5, and I parked 4. How do I park the rest? You're like, that's stupid. Or maybe you're like, I'm with you. But the blanks in the middle are, remember, each blank holds how many things there? Each blank holds how many things? So I did a filling and a sandwich. It held 1 filling and 1 sandwich, right? When I did robots, it held 1 top part, 1 middle part, 1 bottom part, right? So here, how many cars are being held in this parking spot? 1. I must have thought you stacked all 5 on top of each other. Like, I obviously just did not understand what the heck this question was telling me. So each blank that we ever write is holding 1 number, or it's holding 1 car, or it's holding 1 filling, or it's holding 1 part. It's only holding 1 thing there. But above, we list how many options you can choose, but it's still only going to hold 1, right? So I have 5 options of black cars here, and I have 4 options of red cars here, but right now I've currently only parked how many cars? 2. Parked 1 black and 1 red, correct? How many cars do I have left? 7. I don't care if they're black or red anymore. I just care how many cars I have left to park for the rest, right? Because there was no restrictions on these. They could be whatever they want to be, right? So I'm going to start from left to right, but I could start from right to left. I could start in the middle. It doesn't matter. But I'm going to start on the left. So I have 7 cars for this spot now, right? And now how many did I park? I parked a car, and now I have 3 parked, right? So now I have 6. I parked a car here, and then I have 5. I parked a car here, I have 4. I parked a car here, 3. Parked a car here, 2. Parked a car here, 1. And then I have to remember to do my multiplications. Now, we could go 5 times 7 times 6 times 5 times 4 times 3 times 2 times 1 times 4 in your calculator, which would kind of suck, but we could do it. But there actually is there's a better way when you have a number going down by 1 to 1. So I'll explain what that means. So I'm going to use the 5 and the 4 and put those together and say 20, right? Because 5 times 4 is 20. And then this 76543, whenever you feel like you're literally doing a countdown for a rocket to take off, it's a factorial. So I can go 7, 6, 5, 4, 3, 2, 1, blast off. If I can do that, if I can make a rocket go off, it's a factorial. So what does that mean? That means I can multiply this by 7, exclamation mark. This exclamation mark, it's not the 7 screaming. It's not like 7. It's 7 factorial. Okay? So that's 7 times 6 times 5 times 4. So if I wanted to do 100 factorial, I would have to go 100 times 99 times 98 times 97 times a whole bunch of numbers, times 5, times 4, times 3, times 2, times 1, right? And it would do it for me, okay? So if you grab out your calculators, I'll show you where it is. Could you technically go 7 times 6 times 5 times 4 times 3 times 2 times 1? Totally. So you're going to go 20 times. Now, everything we're going to use for this unit is found in the exact same spots. We're going to press math. Now, you could arrow over 4 to the right, or you could just press left, and it gets you there faster. And we're going to pick number 4. The only things we're using for this unit are number 2, 3, and 4. Okay? So, if you want to write it down, you can. It's going to be math over to probability number 4, which is factorial. You won't need these steps because you'll be pushing the button so much it'll be part of your being by like tomorrow. So if we go back to here and press 4, nope, I had to put the 4 in first. 4, I have to put a 7, oh my gosh, 7 math, probability. Wow, 20 times 7 math. So it's 100,800. Now, that's 100,800 ways that you could park 9 cars in a parking garage with a black car first and a red car last, right? Now, why would they use factorials in any other way? Well, if you have 20 times 7 factorial, that's 100,800, right? Technically, can that fit in a 4-box numeric response? No. Could I fit A times B factorial? What's the values of A, B, respectively? It would be 207. Could I fit that in a numeric response box? Yes. So could they do it that way? I've never seen it. I think it's a great idea, you know, personally. They could do it that way, right? And then it would fit in a numeric response box. The word respectively as well, if you ever hear the word respectively, it means in that order, right? So if they say A, B respectively, you'd have to put it 207. If they said B, A respectively, you'd go 720. They don't often flip the numbers just like the letters for fun or anything like that. Okay.